only 3 minutes early.
Yeah.
Yeah, we're good.
And it's going to be pretty bantery because John should be here in just a few minutes. So how's everybody feeling so far? There's John. So you're about
John
halfway
Strand.
through the class.
We are live, John.
John, we're live.
Good to know.
Yes. Yeah, it surprised us all, actually.
Just a
And
shocker.
it wasn't Megan this time.
It wasn't. Look, I did that one time, and I tend to make mistakes once and then have nightmares about it for like the rest of my life. So,
Who
I
did it?
forgot what I was doing.
Push the button.
yeah. Okay.
How you doing today, John?
I'm doing good. I'm just spinning up my virtual machines.
Okay.
I'm running a little late, like trying to get everything going.
That's okay. We had our webcast this morning. That went really well. We got Jerry bombed by all of his people that came to his live.
He's
Team
Simply
Simply
Cyber.
Cyber.
Yeah, that was fun. So they may be joining us. And if you are joining us on YouTube, let us know in the student lobby if you need the Discord role, and we can add you to that as well. But we can't add you to Zoom, unfortunately, but you can still watch it from YouTube.
Yeah, Team Simply Cyber in the house. They're all popping in.
Yay.
We love the
Go
Simply
team always reply.
Trying to bring up Team Viewer. Come on.
There's the right chat. I had the wrong chat open.
You did. You were
I
like,
did.
why? It's quiet. It's a quiet.
Well, I was like,
Nobody's
where's all the
talking.
Team Simply Cyber people?
Yeah.
I don't see them. Now I see them.
Yeah.
I love the Simply Cyber people.
Anyone that may be under a tornado watch, be careful, be safe.
Are you under a tornado watch, Ryan?
I was. I don't know if it's still on. Right now, everything looks fine. We had a crazy thunder boom boom storm for like 20 minutes earlier. Like what, 9 o'clock? But it looks okay now.
It's funny. So Flakinator said they had to go so that they could go to the webcast. So Jerry decided to raid the stream. Thanks, Flakinator. We appreciate it.
Yeah.
We always love new people.
We like it when people come and see us.
Yes.
Brian, do they have tornadoes in the future?
We do.
Really?
I haven't
And
figured out that
that's-
problem.
The scariest thing was we had it was back when I was working on the airport, and we were literally waiting for one of our flights to arrive, and we could see the lights, say 5 miles away. And while we were watching it come in, we saw a couple of flashes on the horizon, and a tornado had gone past less than a kilometre or under a mile away from us. And by the time the tower realised what had happened and what we'd seen, it was like, well, it's already gone. And when the plane landed, they were sort of like, okay. Because they flew right through the hole where we were, where the thing had gone.
That's like that show Manifest.
Mm.
Did you watch it?
Yeah. Well, we saw it go past on the horizon, worked out what it was. By the time we turned around to look at the tower, and the tower had called out on a loudspeaker, "Did you see the aircraft was on finals coming through where it had been?"
If y'all are just joining us right now, you are here for day 3 of John Strand's active defense and cyber deception class. We'll be getting started here in just a few moments.
All
If
right.
y'all have any questions about getting your VM spun up for the class, we're here to help you. And I'll hand over to John.
I got a question. Is my zooming working? You see me zooming in on a command prompt?
I didn't.
I'm seeing
Hold on.
Ryan's
I wasn't
screen.
looking at your screen yet. Let me
Yeah.
bring that up.
I'm zooming in and out.
No, we see your
no.
full desktop.
All right. Now, we try it now.
Nothing yet.
Nope.
No zooming?
No.
No zoom.
Okay.
No
I
zoom,
wonder
zoom.
why it worked the other day, but it's not now.
Because it likes to mess with you.
How about this? Let me try to do it within the VM. Uh-oh, that was a mistake. I am experiencing, like, my mouse just went nuts, everybody. So
This is why we reboot Windows 95 every night.
every night. Let me
3
go
times.
here, come back.
Okay. Let's see. Don't see Zoom.
Yeah. I think this is one of those mornings where absolutely everything is going wrong. Let me kill my team viewer session and then
Okay.
restart it.
Which this should be very refreshing for people to see that even, the seasoned veterans have
Yeah.
technical issues as well.
Yeah.
Yeah, I'm running into multiple problems this morning, which is
They're,
great.
they're
So,
happy little accidents, right?
happy little accidents. All right, so I just killed team viewer. Let's go back. Let's do this.
Mhm.
People like, is that a Mac you're using? That explains it. So
Just not an M series.
it is actually.
Oh, you can't be running the VM then.
Nope, not.
Like
Oh, and we
it's
found out
cloud runs.
why the new VM for the Apples that supports the M series,
Hmm.
it does support M series Macs, but that still doesn't solve the problem with our VM, which doesn't like M series. It just means
Oh
you
my
can use
God.
VMware Fusion on a Mac or an M series Mac. It doesn't change what you can put onto it.
Oh, that is crazy.
So it's still a pain in the butt.
So yeah, I've got the problem here is my mouse is gone completely wonky and it's not in TeamViewer, it's actually in my in my virtual machine. All right. So what we're gonna do, crap.
You want to try and reboot and rejoin?
Yeah, I think I might have to do that.
Okay.
So but that sucks. I apologize, everybody.
Well,
So
better at the beginning than halfway through. I
Yes.
hope I didn't
yeah,
jinx
but
us.
everybody dance. Let's continue talking about
Yes.
tornadoes and stuff.
Yes.
And I'm gonna go
Yes.
on AV mute to try to get this set up and
Okay.
just give me a couple minutes.
Okay.
All good.
Awesome sauce. So we can go back and look at Ryan's.
I
Yeah.
just like to know that it's not only us that has problems. Sometimes the boss has problems too.
Yes.
Yeah, no, I think it's like I'm not entirely like happy this is happening, but it's almost like good for people to see that
Yeah.
again, even technical professionals, if you will, have issues, and we have to do troubleshooting just as much as everybody else sometimes. Just the fact that it's happening live is, well,
Yeah.
good
We
for
love-
y'all to see. John just needs to call like our help desk team.
Yeah.
If it's anything like what I experienced back in the day, like anytime when I was working help desk in a school district, I would get called for different issues, like projector wasn't working, tablet wasn't working right. And not, this didn't happen all the time, but a lot of times you'd like, and this happens with a lot of like help desk and entry level tech positions, but you just walk into the room and things start working again.
Yeah, I know. They would
And-
stand by your desk and everything.
Yeah.
It was,
All
right,
I was like,
everybody.
no, I swear it wasn't working. I promise.
So everybody say a little prayer for me because
Yes.
part of the problem is we have a it wants to update and restart, which I think might be my problem.
Yes.
Oh no.
That happened to me
no.
earlier today. I had to
Ooh.
update.
Yeah, I think
It'll be
that's what's
good.
going
It'll be
on.
fine.
It'll be fine. It'll be
It's great.
fine.
It's
Good thing.
great. Everything is
And
fine.
I think it's one of those things where the like it's all wonky and it won't come out of it until the update is installed, which
Yes.
sucks.
It's going to be great. HK had a question about the upcoming summit. What
Yeah.
question did you have, HK? What it's going to, we don't have the talks confirmed because today is the closing date for the CFP. So, but it's obviously going to be incident response related talks. And we've had
Going to be awesome.
yes, it's going to be great. And it's free. So, I mean, really, what do you have to lose by
Exactly.
coming? And then we do have the post-summit training. We had Wade Wells earlier on Anticast. He had earlier this morning. Some of you were there. Thanks for coming to that, everybody. But he's going to have his class the day after on the Thursday, the 20th, his Cyber Threat Intelligence 101. And then we've got some other 2-day classes, the 20th and 21st, that are post-summit classes. If anybody is interested, I will put the link in Discord with that info.
All right.
Oh, there's John.
Yeah. I
I'm
just
back,
mistyped
I'm back.
Stop tap
ADHD.
dancing.
That was some great tap dancing. That was awesome. Resume sharing.
Didn't
I was
fall on the
doing the
sink,
shuffle ball
obviously.
change.
Yep. You should all see me logging into my ADHD system now. If you can, you should see a big old
Yep.
command prompt.
Let's see. You
Yep,
need to
you're
go to
there.
view.
Yeah.
Okay.
It's
Looks
good.
bigger already.
Yeah, it looks
Looking-
much
looking
better.
good.
It looks like a nice 800 by 600 resolution there.
Hey, you know what's awesome about this resolution?
Everyone can see it.
Students can see it. So, all right, we're just getting fired up. And then we are going to play around with the IP tables block rule that actually shuts down attackers. So let me open up 2 separate Ubuntu command prompts here. We're going to have one side that's going to be running the IP tables rule that actually is doing the port lockout. And then the other one is going to be for the connections as well. This is funny. Now this is like running super slow this morning. It's like, God damn it. I swear to God, am I in a nightmare right now? Make sure I'm wearing pants. All right.
Are you on Punked? Oh, there it is.
Yeah, am I on punked? No,
Yeah.
it's just everything is just broken, like for me. And I had it all set up last night,
Of
but
course.
they're running sprinkler system in a new building, so I had to like move everything, shut everything down, and then bring it back up. So it's been that kind of morning. Wasn't able to get into my office until like literally 10 minutes before class, but that's cool. You know, I'm not mad at those guys. They're doing an
Yeah.
awesome job. I appreciate it.
Do you use the sprinkler system for when you get really hot on the climbing wall?
Yeah, right. That would be nice. Might have some
All
problems
right.
with that. All right, we're ready to go. Here we go.
All right.
All right. So with that, yesterday we did this lab where we were doing honeypots, right? Where we went through and we were creating a port that as soon as an attacker attached to that particular port, it would automatically deny that attacker any access to that system from that point on. And at the beginning, I asked you, what would be your major concern of running a honeypot, right? And the major concern for a lot of people was, well, like the attacker could spoof connections from another system, and then that honeypot would block out legitimate servers in an environment. And I'm going to tell you that's not going to happen. I mean, technically it's possible, but I'm going to get to the technicalities and the percentages and the odds. Never tell me the odds. So we're going to look at this script really, really quick. And then what we're going to do is we're actually going to take this script apart piece by piece by piece. All right. So let me open this up here like that. So we have 2 prompts open, and let's go ahead and just cat out the honeypot file so we can look at the code, and we'll walk through what this thing is actually doing and try to get it set up. Because yesterday we were talking kittens, and this is a great opportunity for me to kind of get people exposed to some bash scripting and a lot of really cool things in bash scripting that one can do. The first thing that we have up here is we have the shebang. And that's basically saying from the shell's perspective that this is going to execute within bash. In your Linux system, there's multiple different shells. There's the Bourne shell, which is just SH. There's the Corn shell, which is KSH. There's the Born Again shell. So Born Corn and Born Again shell. And this is a Born Again shell, which if you're going to learn bash scripting, learn this. You'll have people like, well, you should learn Z shell. You should learn fish. You should learn, no, learn bash first, because everything that you work with is going to be compatible with bash scripting. The little program is just going to kick out and say echo started, which is great. And then we're entering a while loop. There's a number of ways that you can do a while loop. You could do like while squiggly bracket true, squiggly bracket close, semicolon, that's a loop. You could do while colon, semicolon. You could do while space, open bracket space, one space, close bracket. There's a number of ways to create a loop. But what this does is every time this thing runs, it's going to execute again and again and again. It's going to be on a loop that just keeps flipping through. And for each iteration of the loop, it's going to do a thing, all right? So it's going to do something. And what this loop does, the first thing right out of the gate, here, let me open up my YouTube watchers. By the way, good morning, all of you on YouTube. Good morning, all of you on Discord. Appreciate that you all could make it. We've got a pretty good turnout this morning. It's going to start by creating a variable, all right? So the first thing that we do when we're running this is we're creating a variable that is going to be put down here where it's going to be called in IP tables. And IP tables is a really neat little firewall that is built into like your Linux computer systems. And it works out really, really well. And it's just going to take that variable. So if I were to go foo equals bar like that, and then I do echo, could type it right, that would be awesome. And then I do $bar because now it is a variable that I'm invoking. Echo foo. Like that. It's now going to print out bar. So we're creating a variable called IP that we're going to invoke and we're going to run multiple times. And then we have this really long netcat command, which isn't really showing very well. Let's do it this way. There we go. Like that. And let's do cat. So there we go. We have this really long netcat command. Now, whenever you're troubleshooting anything, one of the things I try to teach in all my classes is the concept of ping port parse. And what that means is if you're trying to troubleshoot something, number one, can you ping it? Number two, is the port that you're trying to deal with, is that actually open? And then number three, parse. So if you're writing code, never try to look at the whole, like, you know, the whole line of code, because this whole entire thing looks like an absolute nightmare. It's a lot of crazy things going on, and it's a lot. But if you look at it, it's a bunch of small things that are brought together. The first thing we're doing is we're running netcat. Then we have some shell redirects. Then we pipe it through grep, and we're grabbing the strings received. Then we're sending it through awk, and I'm specifying delimiters as spaces, and we're printing the third value. I'm going to explain how that all works. But we're going through and we're literally breaking this thing up into digestible pieces that you can truly understand what that piece is actually doing. All right. So what I'm going to do is I'm going to take this apart in a separate command prompt. Make sure that you all can see it. And we're going to parse through this. So the first thing that we're going to do is we're going to run a netcat listener. And if we go to like explain shell, this is kind of cool. So let's go ahead and go to explain shell. Right here. You can put that right into explain shell, which I totally cannot do. But you can do like NC minus LNP, and then you can say 1024. And then explain shell will start explaining what that is. Netcat is a Swiss Army knife. It's running in listen mode. Numeric only IP addresses don't resolve anything. And then the port number associated with, you can see the port right there. So explain shell is great because it breaks this down in such a way that it'll start explaining which each one of these different little switches is actually doing at any given time as well. Here we got a big one as well. Here's the script with spoiler protection. That actually has full-on debugging, which is pretty cool. Very, very neat. Awesome. So the next thing that we have is we have some shell redirects on our computer system. On a Windows computer system, you have input, output, and error. All right. 0 represents input. 1 represents output, and error is represented by a number 2. And you can do these shell redirects with all kinds of things where you can take the input and dump it into another output of another file. And it's really cool what you can do with it, but these things can be invoked. Now, with the input and output operators, what we're doing here is we're just kind of cleaning up. So we're basically saying that standard error is going to be put into duplicated standard output, and standard output is going to be dumped into dev null. This is cleaning things out. We kind of want to flush the system. So whenever it prints out like a connection has been received from something, we want to capture that, but we also want to clean that up so it doesn't like muck up the works. So we're literally dumping it into like dev null. And you don't have to worry too much about, how this works. This is just something, if you have output that's constantly mucking up things, this is just a little string that you put at the end of it to kind of clear these things out, right? So then the output of what comes out of this connection, we're going to do grep received. So let me show you why we're doing that. So let's take this string up until that grep statement, and we're going to copy it, and we're going to paste it over here by itself, all right? So I'm going to make that connection. Now notice it says listening on 0.0.0. That means listening for any and all connections. Family is 0 and the port is 1025. Now, if I make a connection to that system from any IP address on 1025, you're going to see another like little command shows up. So for my Windows computer system, I'm going to do my Linux system first. So if I do this for my Linux computer system and I connect to myself, I can go netcat to 127.0.0.1 on port, what is it? 1025, all right? 1025, I've made that connection. On the other side, you can see it says connection from this IP address, source port, and then received. How do I differentiate and only get the data that I want to capture? That is the connection that has the IP address. If you look at the first one, listening on that line does not have the source IP address that's making the connection. The second one does, okay? The second one does. And there's lots of things that you can get in Netcat where it's like connection from, connection died, connection, whatever. But we want to pull down the lines that have the received because that's an established incoming connection coming into this computer system. So I can kill that connection with Control-C right here, and it's killed my Netcat listener. So now what I want to do is I want to just grab only the lines that say connection received. All right. So now we're going to add in the grep statement. We're building this up piece by piece by piece. Okay. So now we're going to build it out. We got netcat, don't resolve any names, be verbose, listen on port 1025. We're going to have that standard error. The message is coming from netcat is going to make its way to dev null. It's a way of cleaning the slate every time. Then we're going to grep the strings that say received. Now notice how this is different, right? So if I go up above, oops, that's not what I wanted. Let me do this twice. So we're going to do it this way first, and then I'm going to make a connection, kill it. So we have listening on, connection from, received. I have 2 lines. However, if I do it this way, notice this listening on line didn't show up. It didn't come out and say listening on 0.0.0.0 and then family 0 port 1025. We're cleaning up that data. I'm only pulling the line that is immediately interesting to me, which is the connection from this IP address has been received. That's because we have that grep statement. So that grep statement basically is saying we only want to pull the lines that have received in that line. Does that make sense to everybody? Because we're going through and we're building this up step by step by step so people understand kind of what we're doing, right? We're running netcat to listen on a port, and we want to pull down only the lines from the messages. Yep, exactly. Grep is a filter, right? We're filtering things down. And the ultimate goal and objective is we only want that IP address to show up. We only want that IP address at the end of this to show up, right? So now whenever I make a connection, same connection again, the only line that comes up is connection from, and notice received has been highlighted. Great. Do you see how we're taking this apart and we're taking it one piece at a time? When you do this, like especially if you're working with AI and Chat GPT, it really, really helps to tell Chat GPT like specifically what you want it to do, and then you stitch it together. All right. So you would never say Chat GPT, build a a honeypot that somebody connects to it. It's going to block them. Let's go ahead and try that. Let's see what Chat GPT comes up with. Let's go to Chat GPT, OpenAI. No, I'm not going to do 4.0 right now. So we're going to do this. We're going to say build a honeypot that listens on port, let's say 1025, just kind of match it up. That in bash, build a honeypot in bash. It listens on port 1025, then blocks all following connections from the source IP address. Let's see what it comes up with. It actually really, really did a pretty fantastic job, actually, to be honest with you. I don't know if it works. What we'll do is oh my God, it used sed and awk to do it. How hardcore is that, right? So let's go ahead and let's see how it does at the end of this. It even logged it, which I thought was really, really cool. All right, so let's keep going. All right. So when you get something from ChatGPT like that, there's a lot going on here, right? Like, what the hell is it actually doing in each one of these steps? And I'm literally taking it apart piece by piece by piece. And it's possible that this doesn't work. It may work. Who knows? I don't know. So far, it looks okay-ish to me. I'm not seeing where. Ooh, it didn't create the firewall rule. It didn't create the firewall rule in IP tables. It's just this program is stopping that connection. So yeah, it's not going to work, but I think that we can fix it. All right, let's see if we can fix it. All right. But I'm taking this apart piece by piece by piece, and we're whittling it down, and we're getting it filtered to the point where we just collect that initial IP address. All right. So I'm going to go ahead and clean up, and looking good. Looking good. There we go. So now we're going to go to the next step. So we've grep received, and I'm just using awk. And if somebody could put in the names of the authors of awk, if you're wondering what awk stands for, it stands for awkward. Or the more correct answer, it actually stands for the initials of the people that created awk. And there's this joke in the world of computer security that is, if you ever get into a problem in life and you require sed and awk to solve that problem, you now have two problems in life, right? It's kind of a pain in the ass, right? But it actually stands for the initials of the authors. Why can we still see the output on the screen? Oh, excellent question. It's going to show up to the screen, but it pops to the screen, but after it's done popping up onto the screen, Jason, then it's getting rerouted to dev null, right? So I don't want it to just continue to load in the screen every single time. It's different. It will show it, but it's not actually going to be in the buffer as well. Ahu, Weinberger, and Kernhagen. Yeah. So a bunch of people with really difficult names got together, and you know what we need to do? We need to create something that's more difficult than spelling our names. And Ahu's like, "You sure? I'm invited." Yeah, sure. Come on, you can come with us as well. All right. So now what we're going to do is we're going to kick it through where we're going to do awk. We're going to identify the delimiters as spaces, and then we're going to print the third value. And the reason why we're printing the third value from this is connection from the third value is 127.0.0.1. So we just want to get that IP address from that connection. So I'm going to copy that whole entire thing. We're going to run it, and we're going to see how it runs different. Some commands just run different. They're built different. Now we're going to make the connection. Now watch what it did. Didn't do anything, right? But watch what happens when I kill the connection. It prints out the IP address. Excellent. So now we built our little program that when somebody does a full established connection, it's going to print the IP address of that computer system. So now we can have it assigned to a variable. We can take this whole thing. By the way, if you notice, I've been skipping these backticks. What the backticks do is it allows you to basically bundle that entire command, and then it just takes the output of that command. And that's the only thing it's going to print. So now I'm going to assign it to a variable like so. Paste it in, run it. We're going to make the connection. Now watch this. We're going to make the connection. We're going to disconnect. And when we do that, it didn't print anything to the screen. It didn't print anything to the screen because it assigned that IP address to a variable called IP. So now I can do echo and I can do $IP like that. And there's the IP address. Is this working for you guys? I want to make sure that people understand if this is, you can come back and you can rewatch it, of course, but if you have any specific questions on what I'm doing on all of this, that would be awesome. But I really want to make sure that people are the kind of understanding, not necessarily exactly what I'm talking about, but the process of putting it together and taking it apart. That's what's really super important for me, for you all to make sure that you get what's going on. And now what we're going to do is you can see right here, IP tables. You can see we're just running an IP tables input protocols TCP, and then we're going to take that IP variable, drop it into that command for IP tables, and then we're going to block any and all connections. So let's go ahead and run it. And I'm going to explain a couple of things here. We're going to open up yet another command prompt. We're going to run TCP dump. We're going to do LO. I don't think I need any. Nah, we'll just go like that. That should work. All right. So now I have my little firewall script is running somewhere. I run it. It's over here. All right. So now it's started. Now I'm going to make a connection really, really quick to it. And that connection's initially going to come through. And then when I disconnect that connection, we now have the echo that 127.0.0.1 has been blocked. When we go back here, there's some really interesting things that I want to show you. All right. The first thing that I want to show you is we have this connection here. All right. All right. This is the beginning of a fully established connection. All right. This is a fully established connection. Okay. When we look at this, do you see this sequence number right here? That is a 32-bit number. All right. That is a 32-bit number. Okay. When we make that full connection with that 32-bit number, if somebody is trying to spoof this connection, they would have to be able to spoof a 32-bit number. And let me show you why. So when I start this initial connection, right, with the sequence number, that's a 32-bit number, the next packet that comes back is a response to that 32-bit number. This is the 32-bit number that it responds with. What is the response to that 32-bit number? KX root, got it. It increments that 32-bit number by 1. Okay, so if we're looking at my screen, if we can share my screen with everybody, it increments that 32-bit number by 1. But what it does next is it has an acknowledgement number, which is a separate sequence number. They call it a SYN-ACK. That is a completely different randomized 32-bit number. Okay, it's a completely different randomized 32-bit number. This is the number that if you're spoofing, it's going to have to guess what that 32-bit number would be. And it is almost impossible for an attacker to spoof a fully established connection by guessing that 32-bit number. A 32-bit number is a really big number, and they have to guess what that 32-bit number is within less than a second. So when you're looking at the size of that number and you're looking at the time that they have to guess that 32-bit number, it's just not feasible. It's not technically, I mean, it's technically possible, right? Because everything is possible, but the idea of it actually happening is incredibly low. In fact, when we're talking about creating these honeypots, the level of risk for an attacker spoofing a full established connection is no greater than every other connection that ever happens on the internet billions of times per day or per hour, actually. All right. So there's really no way that an attacker can just jump in and start spoofing this, right? There's really just no way that they could do that on that. So the question is, why do we use awk rather than awk-f? It's just the way that I did it, James. There's a number of ways that you can do it. You could do it in sed, you can do it in awk, you can do it just with straight cut, specifying a delimiter. It's just the way that I did it, James. There's just a number of ways that you can do it. All right. So that's why this particular thing is really, really super cool. And it actually works. There's actually a version of it that you can run on Windows as well, that you can do. So let's see if we can do Chat GPT, and let's see if we can get this to work. See if we can get this to work. But I got to add in IP tables. So let's go down here. We're going to modify it. Blocks all following connections using IP tables. There we go. Let's see if it does it. It didn't use IP table. Oh, no, it did. There we go. All right. Should we give this a shot, everybody? Let's give it a go. All right. There we go. Oh, man, that's not what I wanted. All right. Let's type in the clipboard text. Good comments in it. Now, somebody was asking, how can we do logging? Now, it's kicking out the log file to var log honeypot.log. I didn't ask it to create that log file. I wouldn't have done it that way. I'm going to show you a different way that you can do this with IP tables. All right, we ready? And it is on port 1025, I think. There we go. Plus X on our chat GPT.sh. You guys ready? Let's see what this does. I've never done this in a class before, so. All right, here we go. I accepted the connection. Kill the connection. And let's see what it did. Oh, it did actually create it. Awesome. Let's try to flush it and let's try it again. Let's make another connection. Was it 1025? Kill the connection. And let's list it out. No. No, it didn't work the second time. Am I reading that right? Yeah, it didn't work the second time. Says it's open. I think it worked the first time and then it puked out. Nope. Yeah, I thought we did in Chat GPT. I thought I told it to do 1025. Yep, port equals 1025. Human 1, AI 0. No, but let's say that we had this. Yeah, all of our jobs are safe. Let's say that we had this. What would we actually do to fix it? Well, we take it apart piece by piece by piece, right? And it does have some logging built into it. So let's see what it's actually logging, see if it logged anything. Go over here. Oops. Paste it in. No, didn't even log it. So yeah, you know, humans are still safe. We still have jobs. But I'm going to tell you, this does look really close though. So it's got to be just some stupid error on it. But all right. So whatever the reason, it didn't work, y'all. But we could build it step by step by step. And there's also some things in there that do work well. Yeah, ping port parse, Schmooze said. We would literally go through. Well, tell it that it didn't work. That did not work. Let's see if it does it. I can fix it. Here's an improved script. Why didn't you start with that? All right. We got to move on, but it is fun, right? Let's say it is fun. Yeah, this is the one. Did you generate it step by step, KX root in Chat GPT? Yeah, I should have used the new model, right? Okay, but you had it build it step by step, right? You just didn't throw the whole thing in. Because yeah, that's where you run into problems with Chat GPT. Yeah, I could try 4.0 at some point. Yeah, feed it in step by step by step. So, all right, but that was a lot of fun. Like I said, I like this lab because some people were talking about like, okay, so let's say you wanted to run this on an enterprise basis. So they're safe, but I was using the older model. There is a number of ways that you could make this work. One of the ways that I would do this in my own script is I would do jump to log -- log prefix. So what I would do is this, let's go ahead and do VI. Like I would take this IP tables rule and I would take this rule right here. And with IP tables, I wouldn't have done the way that they did it where they're creating their own log file. I thought that that was a bit clunky. But what you would do is you would jump to log and you do -- log - prefix. And then you would put in like what you like honeypot. But that's how I wouldn't do it that way. You would do log first, then drop. You would always do log first, then drop, and I can fix that. But IP tables has built-in capabilities to do logging on its own with -- log prefix, and it would send it directly to var log messages, which is cool. Or you could just send it to a separate file. If you do decide to send it to a completely different separate file, you can do something like FileBeat, which is a really cool like tool that'll watch any files, any modifications to files, and it'll ship it off to your log instance. So there's a number of ways that you can do this to get it so it works on an enterprise level. All right. So it's really, really super cool. All right. So there's the script. This is what it looks like when it runs. And then this is, if you hate yourself, like, I mean, truly deeply hate yourself, right? You can do it on Windows too. So you can do it in like standard scripting on a Windows computer system. It's very, very similar. This is kind of funny. 4F delimiters equals, does anybody know what delimiters this actually is? This is so effed up. Anyone know? What's the delimiters there? All? Pretty close. In Microsoft batch scripting, that means semicolon, space, and I think comma. And that's not really documented anywhere. For Microsoft, they don't really document that very well. We specify 4 tokens as though we have 4 things coming out. And then we're grabbing the fourth value, which we set up as %, This is for a batch file. That's why there's 2 separate percents. We start up our netcat listener. We have the same thing where you have duplicated standard output, standard errors going into standard output. We're finding the string from, because it says connection from, and then we set the IP address variable to I. And then we do netsh adv firewall add rule name, name equals delete, direction in, remote IP address is the IP variable, local port is any, protocol TCP, action block. So that is another way that you can actually do this on a Windows system too. If you're so inclined, you can do it on Windows as well. There's also a number of different tools that convert this into, somebody said, Strand.js, I'm betting you've done this exact same script 10,000 times over your entire career. No, I would probably say I've probably worked through this script and taught it 30 times, honestly, to be completely like set up. You can also just get a PowerShell script that does this for you. Like you could totally do that. Not a problem. Just totally set up a PowerShell script. Here's one from Mr. Foss that does this exact thing via PowerShell as well. If we could switch my screen over to my slides, there you go. So this is one from Mr. Foss that does it. So what does this buy you? Okay. So let's spend a couple of moments and let's talk about the why factor for this. Because you can set this up on multiple hosts. The other thing that you can do is you can set this up on one honeypot host, and you can literally have scripts in your environment that automatically take these IP addresses that are making the connections and then make block rules on internal firewalls to shut those systems down. I can talk about it now, but one of the former students that took this class like 7 years ago worked at Apple Computers, and they set this up on the outside of their IP address space. And they set up these honeyports, they pulled the file, and then they automatically created a dynamic blacklist across all of their Cisco edge routers that was blocking any and all traffic coming from the IP addresses that were hitting these honeyports. The idea for the people at Apple, for the security team, and I don't know if they're still doing it or not, this was a long time ago, was there's 2 magical things that they wanted to deal with. The first thing that they wanted to deal with is reduce noise. So when they ran this and they set it up on the outside of their environment, just the random white noise to dynamically blacklist or deny list IP addresses at the edge of their router dropped the amount of noise and the amount of connections coming into their environment. I want to say that they dropped it by like, I think he said something like 90%. So 90% of the traffic that was hitting the outside of their environment that was hitting these things was just random scanners, random bots, random skidiots, all these different random people. And what that does is that really refines your IR process, because you're not going to go through and try to dig through a whole bunch of noise that honestly just isn't something you want to deal with in an incident. That's number one. Number two, and this blew my mind, the logging functionality on their firewalls were logging all of these connections that were coming in from skidiots and just random noise that was hitting the internet. As a side benefit to this, by doing this type of filtering, Apple Computers saved several $100,000 per year in log storage from their firewall logs. So think about a company like Apple, right? And you have people that are scanning the internet constantly. Every time a log came in, or every time a scan came in, it would generate a log, it would generate an alert, it would generate all of this stuff that has to get stored in the cloud. Or at that time, it was pretty much Apple's own computer systems. This reduced the total storage that was required for all this white noise. It allowed them to fix their signal to noise ratio. And Flakinator said it helped their SOC analysts get a little less crazy. Absolutely. So when you're looking at this, and then profits for Apple went up. So seriously, these are the types of things, folks, that we really want to be doing. Yes, this person did in fact get a raise. For doing that. So when you're looking at IDS technologies, think about the downstream impacts of cleaning this up with cyber deception on it. If you're cleaning up all of that, and that's less traffic that's hitting your firewall, that makes your firewalls more efficient. That makes your logging more efficient. That makes your IDS IPS systems run more efficiently, which means your resources that are taxing onto your IDS IPS systems and firewalls, you don't need to have the firewalls that are the absolute scary top of the line. Maybe you can go one step back because you're cleaning the data coming in as well. How many entries can IP tables hold for blocks? A lot. They actually did it at their edge routers. But if you look under the hood, this is a great question, Vlad. If you look under the hood at almost any commercial firewall vendor that's out there today, almost all of them are running Linux IP tables under the hood. Seriously, it's like that meme of the two astronauts, and one's like, wait, all these firewalls are just IP tables under the hood, and it's got the other astronaut with the gun that says always has been. But yeah, it always has been. And the reason why they do this is because IP tables is running at like the kernel level. It's running wicked fast and it's super efficient. If anybody is like, no, we're developing our own firewall from scratch, they're morons. IP tables is the cat's pajamas. Yeah, and you could totally put in rules that would flush these connections or these rules out every 48 hours if you wanted to set that up as well. So why not run these everywhere, right? It's really simple, little to no impact on production. They're low interaction. There are some potential issues. Messing with vulnerability assessment scanning. You can create exceptions and do authenticated scanning. If you put in your firewall rules, a rule right above them, since firewall rules are handled sequentially, you can put in a rule right above that says the IP address of the vulnerability scanner automatically jumps to accept, and it'll never trip these alerts. You can do that on Windows. You can do that on Linux. You push this out and your vulnerability assessment scans will work absolutely fine. It is possible and likely that an attacker will use these scripts to block. Really hard. Like seriously, this risk is the same for every web server, every SSH server, every cloud server on the internet. They're all based on sequence numbers and TCP/IP. You're going to have this problem no matter what. It has nothing to do from a risk perspective with the honeypots themselves. All right. So now we're getting into my next tool. We're taking this up a couple of notches, right? We went through and we talked about this tool and it's great and it's wonderful, but wait, there's more. The next tool in the next lab that we're going to get into is port spoof. What port spoof does is instead of doing a tripwire that blocks the attacker, F that. Instead, what we're going to do is we're going to blind the attacker with an absolute smokescreen. We're going to create white noise. Port spoof generates random responses to service identification requests. If you scan the system multiple times, never do these systems come back with the exact same ports and the exact same services behind them. And this is what it looks like when it runs. Like literally every port appears to be open. And when you're doing a service identification scan on every single port that appears to be open, every port not only looks open, but port spoof like kind of spoofs an actual service identification back to the vulnerability assessment tool that's out there. So we'll go through the lab here in just a second and let's get started. So this is another tool that is in the Unix side of your VM. So we're going to do the port spoof lab. And really, really super cool. It is installed here. And you don't have to actually go to that directory. You can run it wherever you want. But if we go to usage, you can get help. And then we're going to go through the scenarios. So the first thing that you would do is become root on your system. So we're going to go ahead and make sure we've got a terminal. Once again, if your terminal isn't opening for you because Microsoft is getting weird with the updates, you can totally just go to the command prompt, or sorry, go to the start button in the lower left and just type bash, and you can invoke bash. So we do a down arrow and we select Ubuntu 1804 and become root on it. And password is ADHD, and then you just follow the directions. IP tables, target NAT, pre-routing. We're going to create a rule that anything that's coming in on any port whatsoever, this is a range 1:65,535. It's going to jump to redirect to ports 4444. Port 4444 is where port spoof listens. So port spoof only actually listens on a single port, but we can use the power of IP tables to reroute all the traffic to the system to that port. And then we run port spoof. Then from your Windows computer system, you must run this from a Windows computer. You actually have Netcat on your Windows computer system in the tools directory. So in here, you've got Netcat, it's ready to go. You can make that connection, but it has to be from your Windows computer system in the tools directory. So you can run Nmap, you can run Netcat, you can run all these different things. With this one, we're just running Nmap, which is installed. You don't have to be in tools. And we're just running it against ports 1 to 10. And all those ports will come back as open. Then you're going to do a version scan, and they're all going to come back as open, but TCP wrapped. Now we're going to up the game with port spoof. We're going to run port spoof, and we're going to run it with a signatures file. This is where the services that exist are now going to get randomized. And I want you to basically, it'll record it automatically for you. Like, how long does it take to run a port spoof, run a port scan with port spoof and without port spoof, doing signature verification on that as well. So take a look at that time, because we're going to do some math at the end of this. All right, so here we go. Oops. We do this. And there you go. So this will give us, like, you know, the break and then running port spoof. Sometimes it takes a while for port spoof to get the responses back, because that's literally what it's doing. And we resume at 30 after. All right, everybody, get to it. I'll see you on the other side. All right, everybody. Try to come back in a nice, kind, gentle sort of fashion. It's kind of like me nudging you awake, getting back to it. So I see this Broadcom thing is just an absolute, just crazy. Like we have a whole bunch of servers that are just shot. Like we need license for servers for, we have this thing called, I think it's called Shell Grinder, which is bypassing AV engines. And yeah, we need more licenses for that. And then we also, from the migration, the existing licenses are coming back as deactivated licenses. So it's been a good time. It's been a good time, Broadcom VMware. Way to go. Yeah, no need license. So just crazy. How dumb would it be to try to recreate these tools using Netcat? You know, you can do anything with Netcat. I had a friend of mine that actually completely recreated a Lotus Notes database instance as a honeypot in Netcat. Don't do that, by the way. It's a bad idea. Is it possible for even BHIS to even move away from VMware? Yeah, I mean, hell, anything's possible, right? We could do Proxmark, we could do a VirtualBox or whatever, but it literally means completely rebuilding our entire system stack and our entire infrastructure. A lot of these things seem like, well, yeah, you just switch, and it's not that simple. Because it's not just the virtualization platform, but it's the instrumentation around the virtualization platform. It's kind of the same thing whenever we moved away from LastPass. When we went to Secret Server from LastPass, seriously, but we are here to pay for the classes so that you buy licenses, right? When we went away from LastPass, that was a huge conversion and a huge lift. And I think Broadcom knows that, right? Like they know they can get away with it. They can treat you like garbage. So I really hope that no one here works for Broadcom. I'm sorry. 30 minutes into the Big House episode. Oh, thanks. Is my shoulder still suffering? No, my shoulder's much better. But let's get to this lab. Let's get to this because we're going to have more labs. All right. So a lot of explanation as far as what this tool does, but let's get right down into the nitty and gritties and let's get this thing working. We're going to click to reconnect and we're going to do some port spoofing. And once again, this particular tool, you'll see, especially at the end, just how devastating this particular tool actually is. The first thing I'm going to do is I'm going to flush my IP tables rules. There we go. And then we're going to start it out. I'm already root, which is great, but I'm going to create my IP tables rule in the NAT chain. And we're going to type in that clipboard text. There we go. And once again, what this is doing is it's rerouting the traffic between ports 1 to 65,535 to port 4444. You can change this to different groups of ports. In this example, I just did all ports, right? But you can totally set this to be like ports 1 to 79. And then you have port 80 is open. And then you can say from port 81 to 442, right? You can basically set in the different ranges on this as well. Someone posted this earlier in the chat. It seems suspicious. Yeah, I don't know what that is. So I'll have to have somebody can look into that. That would be awesome. So we're creating that rule in IP tables. I'm going to get my IP address. My Linux IP address is 172.21.6.72. Remember, your IP address will, in fact, be different. So we're going to go to port spoof and we're going to execute port spoof right now. And right now we're running port spoof just absolutely simple. There's no different version spoofing of any of the services that we're dealing with on the system at all. We're just doing it real basic. So now we're going to do nmap. We're going to do ports 1 through 10. And then we're going to run our simple scan and it's going to come back and it's going to say that all of these ports are open. Now, if I run that with a few other options, I can do -- reason, and it's going to come back and it's going to say received SYNAC. Just going to take a second. There you go, received SYNAC. But now if I kick this up a couple of more notches, I can actually start doing a version scan as well to get more information about what those particular ports are actually doing. So now we're going to do -SV, lowercase s, capital V, and it's going to come back and all of them are going to be TCP wrapped. And basically TCP wrapped just basically is there's nothing that comes back. You do a SYN, you get a SYN-ACK, you run a couple of things. There's nothing to identify what the version of that port is for the service, because it's effectively not really a service. Port spoof is responding with just empty like responses. It's just kind of sitting there. Now, believe it or not, this is actually a really, really effective way to mess with an attacker's life. GBL said, can't the attacker just run the scan multiple times and look for them that do not change? They absolutely can, GBL. Sit tight. Hold that thought. We're going to get to it here in just a couple of seconds. All right. Just sit tight. So one of my friends, George Bakos, created this tool. He called it Tiny Honeypot. There's another tool called Tiny Honeypot that's different, but he called it Tiny Honeypot a long time ago, where you connected to the port and it just gave you a pound prompt. You would type something and it would give you a pound prompt again. You type something else, it just gave you another pound prompt. You disconnected and reconnected, just gave you a pound prompt. Just giving an attacker a simple pound prompt on a Linux computer system can keep that attacker entertained for hours. Just simply crazy what you can do with that. And they start running things like they start disconnecting from their VPNs. They stop going through Tor. They make direct connections. Once they think they got something, they just do not let it go at all. All right. So now, once again, we're going to kick this up a couple of notches with our Spice Weasel. I'm going to kill port spoof. And now what we're going to do is we're going to run port spoof with the signatures file as well. We're going to do this. We're going to copy. And we're going to paste that in. And now we're going to let it run. All right. So port spoof's running. And if I'm just going to do, let's just do port 1 with a version scan, it's going to come back and it's going to attempt to identify what is the service that's on port 1. One port only. Just a single port. One port, one service, just one port, one opportunity, one shot. You got to lose yourself. Come on. One port. Just one. One single port. Okay. We ran one port and came back at, what did it say? Done, and it took 32 seconds to run one port. If I do 10 ports, it's going to take a little bit longer. One shot. Do not miss your chance to blow. This opportunity comes once in a lifetime. It sucks. Like my kids are like, wow, Dad, that's like some really classic rap that you're listening to. When I was a kid, since we're waiting on this thing to come back, I'm going to tell a little story. My daughter, like my wife and I, when my wife was pregnant, we would walk constantly at night, just constantly, just going through and walking around this lake that was near our apartment that we were renting in Denver. And when my daughter was born, she wouldn't go to sleep unless she was like being bounced, like she was being walked. And then if you stopped, she would totally just go like crazy, right? But we found out if we put her in a car seat and we drove around listening to the rap station in Denver, which at the time it was like Exhibit, it was Eminem, it was 50 Cent, it was Dr. Dre, she would go to sleep, just boom. So there was a lot of, you know, that era of rap being played in my house. My daughter just recently is like, I put together this playlist that I really like. It's all classic rap. And she's listing off all of the people. I'm like, so about that, when you were born, you couldn't go to sleep unless you were listening to the rap station. It's pretty crazy. But now our scan is done. Look, check it out. Our scan is done and it took 41 seconds to run. We'll just round that up to 42. Okay. Now this is a direct virtual machine to virtual machine connection on the same interface. And it took 40 seconds to scan 10 ports. All right, folks, math time. How long is it going to take in hours to scan 65,536 ports? Quick, folks, let's do it. So we take 65,536 ports. We divide that by 10, and then we times that by 41. What do we get? More than 41 seconds. And then divide that by 60, and you get the number of hours. How many hours? Haircut Fish nailed it. I think it's around 73 hours, if I remember correctly. It's like 76 hours, like that. So somebody recommended earlier, why doesn't an attacker just run this twice and see which signatures don't change? Does that answer your question? I kind of deferred it a little bit. But does that answer your question why you wouldn't run this twice? Can't. And the reason why you can't is, but sure you can. I mean, you totally can. It's just going to take forever to do this stuff. All right. Now, do you need to run something like port spoof on every single system in your environment? Hell no, you don't have to. But you could throw port spoof on like one system per subnet. Let me show you this. Okay, so we got port spoof running here, and I'm going to do this instead. All right, so I'm going to run nmap, but I'm not going to put every single port. I'm going to let nmap do its top 1,000 ports. All right, I'm just going to hit enter. Now, this is what a pen tester or a hacker sees. All right, this is what a pen tester or a hacker sees. When the attacker lets it run for an hour, do they have any indication that something really bad is happening? The answer is no. You can hit spacebar and nmap's going to give status. It's going to say, I haven't completed any host. There's one host that's up. I'm currently doing a services scan, and I currently have 19 minutes remaining. All right. When you're running this, all right, when you're running this and you're running nmap, as an attacker, nmap is not like in real time dropping the results into a file. It'll flush all the data once it's done with the scan. And if I'm scanning an environment and I have 1,000 systems that I am scanning in that environment, and I'm running it through nmap, I will probably know something's weird after about 2 hours. All right. I'll probably know something's weird after 2 hours. If I start figuring out that something's weird, I could do a sniffer and try to look at the packets, but I'm still going to see responses coming from systems. You're not going to want to like kill that scan. You can use Rust scan. You can totally do that. You could also use mass scan, which is a lot faster, but neither of those are going to be doing version identification for systems. So if you're running Nessus, Nessus will just sit and hang. The only thing you can do is kill your entire scan and start over. So what you can do is you can put this on certain network segments in your environment, on the outside or even on the inside, and you will absolutely tar pit any attacker that's coming in. And this goes back to detection time plus reaction time must be less than the amount of time it takes for an attacker to break into your network. We just took the amount of time it takes an attacker to identify what ports are open on a computer system, and we just kicked it up by what, a factor of 1,000? So this is an incredibly effective way for an attack to just be completely destroyed, and the attacker really won't know what's going on. And once again, it's going to take them time to troubleshoot that as well. So where would you put honeypot-like technologies on this as well? You know, put it, somebody's trying to do PS exact, pass the token, our desktop, pass the hash. All of these different things could be generating alerts on the inside of your environment that kick off your logging server. And that brings us to yet another tool and yet another lab, Kipo and Cowry. All right. Cowry is different than a simple honeypot because it allows us to interact and create and emulate an entire service. In this situation, it's emulating an entire SSH server. All right. Now you can add multiple commands to the SSH server. You can modify them. There's a bunch of tells for this SSH server that you can identify that it's a Kipo server, but you can change all of those different values. It is an amazing SSH honeypot. and it allows you to intercept, capture logins by activity from attackers. And then you can even see what are the commands the attacker is running on the attacker side. So you can use this for annoyance and you can use this for attribution. At the end of this lab, I will tell you how that works. This is from an actual incident that we were working with like a number of years ago. And what it was is the attacker would gain access to a system via SSH. It would change the permissions on these different files. Then it would make a directory for plugins. It would kill if there was an existing, the name of the backdoor was Linux Time, and it would kill it because it was updating it. And then it would remove the old version. Then it would download the new version from this IP address, and then it would execute the new version. So I want to spend a couple of seconds and talk about threat intelligence feeds. All right. So whenever you're looking at threat intelligence feeds, most threat intelligence feeds are designed to like give you what an attacker is doing, right? What are the current raft of attackers doing out on the open internet? What are their tools, techniques, and procedures? Most of the time, whenever you're looking at threat intelligence feeds, the only thing that they're really giving you are attacker IP addresses, and they're giving you URLs that attackers are using. That's usually what you're actually seeing with most threat intelligence feeds that are out there. The problem with threat intel feeds, especially whenever you're just boiling it down to IP addresses and domains, is those are IP addresses and those are domains associated with attacks that happened in somebody else's environment weeks, months, if not years ago. That's all threat intel from the past. If you're looking at really good attackers, they aren't going to be reusing the exact same IP address again and again and again. And in fact, once they show up on a threat intelligence feed, it's very, very common for the attacker to immediately move on to a different IP address. Another thing that we see are domains. Like one of my friends worked at Dyn DNS. So Dyn DNS is a really cool dynamic DNS provider. The problem with Dyn DNS and like selling domains is most DNS providers and most domain providers have a refund period where you can buy a domain and you can own it for like a week to 2 weeks. And if you don't like it within that week or 2 week, you can get a refund associated with that domain name. We see attackers still to this day that will find DNS providers. They will stand up a domain, they will run an op for a week or two, and then they basically go back and say, you know what, we're done, we want a refund, and then that domain goes away. But that domain still shows up in it still shows up in threat intel feeds as a deny listed domain, right? Yeah, newly registered domains are always suspicious, right? So attackers are constantly moving in the front. So think of like threat intelligence as this great big wave, right? The attackers are riding right at the front of that wave, and they're constantly keeping ahead of that wave. All of these things in your threat intel feeds, they're usually old. And that doesn't mean that they don't have value. They absolutely do have value. There's a lot of script kiddies. There's a lot of automated malware. There's a lot of ransomware groups that will use domains and IP addresses for weeks because it works. And the organizations they're going after, they don't subscribe to threat intel feeds. They're not getting updated very quickly. So there is value to that, right? There's absolutely value to that. However, if you're a mature organization and you're buying threat intel feeds thinking it's going to provide a ton of value to you, depending on the threat intel feed, of course, it's probably going to be somewhat limited. It's going to be something that you're going to look at. It's something that you're going to review, right? But the utility is going to be less. I want to juxtapose that threat intel with a honeypot like this on the outside of your environment. What we're seeing with this Keepo, and this came from a real incident, is we now have every command that the attacker ran. What can you do in your environment if you have a list of every attack or every command the attacker ran on a honeypot system? What should you do? What should you do in that situation? Got some people typing. Unplug the printer. Yep, TTP updates and look for these commands everywhere. create rules to detect these particular commands being used. Excellent. Very, very good. All right, let's keep going. Let's go through this list. Let's keep going with this. Keep him engaged longer, right? Keep him engaged longer. I think that that's a great idea. We see a directory, Etsy plugins. What do? Across every one of our Linux computer systems, if we see that they're trying to create a directory called Etsy plugins, what do we do then? Oh, here we go. Yep. Check to see if we have an Etsy plugins directory on any of our systems. Same thing with Linux Time. Are they running? Do we have anything that's running Linux Time? Yes. And you could totally hire Black Hills Information Security for your deeper needs. But the other thing that I love about this is this command in this particular incident, this company that was compromised, when we got them on the honeypot, but we did find some compromised computer systems, and it was making a reverse connection to the same IP address, this 119.1.109.43. We were able to sit down at that environment and say, was there any systems in that environment that were making outbound connections to that IP address? And sure as hell, we found a handful of computers that were making connections out to 119.1.109.43. So when you're looking at honeypots, when you're looking at the cyber deception, you shouldn't look at it as just, we're going to mess with attackers. What we're going to be doing, or like a step bench said, hunt through SIM logs looking for IOCs. You absolutely can do all of those. That's great. But this is threat intelligence. This is threat intelligence. That's not a list of threat intel feeds on attacks that happened months ago on other people's systems. This is threat intelligence that's telling you what the attackers are doing against your environment right now. And that, as Ed just said, that is actionable threat intelligence. It isn't threat intelligence from someplace else. It is threat intelligence of an attacker that is targeting your organization right now at this moment. So if we're looking at Cowry in the enterprise, we can pull all of this up. Are they trying to set up a simple backdoor? Are there any specific files that they're trying to go after? Is it a targeted attack? Is it a simple DDoS booter? We had some lab servers at Active Countermeasures that one of our interns set up. I mentioned this on day one. One of our interns set up the server for Active Countermeasures. We were creating more blog posts. They created a weak password for some test accounts, got popped, and we were able to pull down the history, and the attackers were just doing DOS attacks. They were just loading booter DOS attacks. That's all. So we got really, really lucky. That's great. Do they have valid user IDs and possible passwords? Now, if we see them trying to log in with just root, tor, admin, whatever, that's general script kiddie things. But if they're logging into BHIS as D Brown, if they're logging in as Ryan, if they're trying to log in with Strand JS, and the passwords aren't just random goofy passwords, but it looks like they might be real passwords for those of us that work here, does that change the calculation of us assessing the attacker coming after us? Absolutely it does. It absolutely does as well. So with this, once again, I'm driving this home. This is going to be something we're going to deal with a little bit more. We are absolutely starting to look at this through the lens of actionable threat intel. If they're logging in for these accounts, and these accounts are real accounts on our domain, we now know that we're not dealing with a script kiddie. We're not dealing with automated attacks. We are straight up dealing with a targeted attacker that is coming at our organization. And that brings us to the Cowry lab. Now, this particular lab, just so you all know, it completely resides in Ubuntu. All right. There is absolutely nothing in this that you're going to be doing that is going to have anything to do with Windows or anything like that. We're going to do IP tables. We're going to flush the IP tables rules. Make sure, list them out. So we're good there, but you're only going to be connecting to your local system, which is pretty easy to do. Also, you can reboot your computer if you want. That's another good thing that you can do as well in between some of these labs, but we're going to be doing Cowry, right? So this lab is, once again, it's going to take us a while. These labs are taking a little bit longer to set up. We've got the project. Let's make sure that Cowry is actually a live project. What do we say, huh? Hooray! It is actually still a live project. That's awesome. It's in the op directory. This is the config file, which gives you the straight configurations. And then, oh, I got to put in a line break there. Now with this particular lab, it does not want you to run it as root. In fact, it'll give you error messages if you try to run it as root. So you're going to start out by doing cd into opt Cowry, like so. Then once we're in the Cowry directory, you just do bin Cowry start. Super easy to do. There we go. Now it's running. Very, very cool. And then we have some commands to like check its status. You can check to see if twist D is running. And then you're going to SSH into your system as like whatever account you want, really. So to do that, you just open up a second terminal over here. And then you do SSH and, well, I can just paste this whole thing in. Type clipboard text in. And then you're going to be able to connect. It's going to ask for the password. So whenever you try to connect, you can try to connect with like a password of 1, 2, 3, 4, 5, 6. And you're going to see these passwords come through and you can check the logs. If you want to log in as a legit account in Cowry, do root at localhost, and you can just give it a password of 1, 2, 3, 4, 5. And it's going to come back and it's going to give you a full login. If you try to log in with an actual root level account, it's going to get you in. And then I am inside of Cowry at that point. So that is kind of a setup for the lab. But down here at the bottom, we're going to view the logs coming into it. And then I also have a user database file that you can modify. You can change the file system and you can change like credentials and these types of things. So, and I've got some questions at the bottom. So this lab is going to take us up to and through the break, and we're going to resume again at the bottom of the next hour. So 30 after. We're going to resume at 30 after. So I'm going to put in the do this lab. Oops. There we go. There we go. Do this lab. We'll resume at 30 after. And I've got some really cool things I'm going to show you that you can do with Cowry. Don't go anywhere. Like you're going to want to see this. There's some really cool things. Like I haven't told you about like the coolest thing that Cowry does. So let's get to it. We got a question new to all this. Just wanted to take a few seconds to say thanks. No. We appreciate it. Once again, we have a bunch of cool people. We have sponsors right here. Check out Barricade. They're awesome just for helping out. And then also Arnie Bellini, Bellini Capital is just really cool too. We really appreciate all the people that are doing this. And I have a question about that at the end of class today. I want to talk to you all about that as well. So with that, get rolling. If you need any assistance, please let us know. All right. Sorry, I'm a hair late. They just had lunch delivered. We buy lunch for everybody in the office, and it got here a little late. So I just had a whole bunch of quiche. I'm a little bit wired. Woo. Mm. What hair? All right, let's do this Cowry lab, huh? All right. So many labs. It's funny, over the years, I realized the less I talk during my classes, the better the classes scored. So people are like, well, I really like that class. The best thing I liked about that class is John shut up, which is great. So I've already got Cowry working on my system, but we can still go through the commands here. We'll go ahead and do Cowry status, just kind of run through the copy and paste, just so you all can see it. Yep, it's currently running. And then you can check to see the Python environment twist D, make sure it's running like so. Here we go. ADHD is the password. There it is. It should be 4 hours of just staring into the camera. Yeah. So here's what I want to do. I don't know if we're going to do it next year or the year after, but what I want to do for RSA is I want to hire a very like old guy in a suit. Okay. Old dude in a suit. And at RSA, the only thing in our booth is going to be a folding table, a chair for the person to sit, and then a stack of cards. And if people come up, they're like, oh, this is the Black Hills Information Security booth. It'll still have the little white thing up above it. And the only thing that it was cool, the what is it? FFG, IRB, whatever, just hands them a card. And on that card is a QR code that literally just starts to capture the flag. And that's the only thing that guy does. Just sits there all day long and makes eye contact with people as they come by. And if they come up and they're like, what's this table? He just quietly hands them a card and then goes back to like reading a book. The books could be like Hacking Exposed Windows 2000 or Hacking Exposed whatever, and just sits there and just hands out cards. And then something amazing happens when you get those cards. I just want to do such as this contrary thing to RSA, like the bigger, louder booth and all of those things. And just literally just handing out cards, starting a capture the flag, and that's it. So it could be a badge. It could be a badge to a conference or something. I don't know. It might be a lot of fun, but that badge idea is a good one. All right, so now I'm going to SSH into my system, and let's go ahead and just run that. And I'm just going to log in as root. Like I said, if you actually want it to log in as root, I think that would be good. Some is want us to trust a QR code. That should be at the bottom. Sega Media, it should say, trust me. And that's all it says, right? All right, so we go through, we connect to the system. I'm going to log in. Well, the first thing I'm going to do is I'm going to do a failed login attempt. Put in a password so you can see in the logs what it actually looks like when the authentication requests come in. All right, so now if I actually pull out the logs right here, if I go into the Cowry log directory, you can see what was the password that somebody used to try to log into this SSH server, the root system. I'll go ahead and CD into that. We'll do tail. What do we got? Cowry.log.json. Oh, that 20. Cowry.log. That's all I want. There we go. Cowry.log. And then here you can actually see the authentication requests coming in for the different accounts. So you can see what was the authentication request that was made. How was that authentication request made as well? The other thing that you can do with this, and I'll show you here in just a little bit, we can just tail -F. So what I'm going to do is do this, and we're going to do tail -F, the Cowry log, -F, Cowry log. So there we have that running. And then I can close this connection. Let me just try to log back in to a different connection. Here we go. Oops, that's not what I wanted. Go ahead and log in. Log in as root. Actually, no, I want to control C that. Let's log in just as localhost without root first. Follow the instructions. All right, so I'm going to put in a whole bunch of A's here. Oh my God, we could have them dressed up in a black cloak. We could have that person change throughout the day, or different people. One would be just a black cloak. One would be a person in a hacker hoodie. The other person would be in like just nothing but like they could be different hacking characters. Someone could be dressed up like the characters from the movie Hackers. We could have somebody dressed up in a suit like the Matrix. We could have someone with a hoodie like Mr. Robot right there, the hoodie and the Mr. Robot. They just kind of rotate through the characters. That's a good idea. I like that as well. All right, so I tried to log in and it said authentication failed. Please try again. And here you can see the user ID is ADHD, and you can see the password actually came through. Now, this is where I'm talking about it, like the getting these logs becomes really, really important. You're going to see that here in just a little bit. We can see these authentication logs of what they're trying to do and trying to log in. But now what we're going to do is we're actually going to try to log in as an account that's going to let the hacker in. So we're going to do root at localhost, and then you can put in any password you want. I can put in a bunch of B's. You can put in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do it again. All right. So you do that, but now you log in, and regardless of whatever the password is that you try as the root account, it's going to log you in to this particular computer system. So here you can actually see those logs coming through. You can see that this root account was logged in. We now have a shell on this particular computer system. Rock on, easy peasy. And now as I run commands like the ls command, it's going to log those commands. So it's going to say command found ls. I can do ifconfig like so, and it's going to come back and it's going to say command found ifconfig. We can do another command like, let's do who am I? Or just ID would be a good one. It says that we're running root, and now we're capturing all of the commands. Now, sometimes there's going to be commands that maybe don't work. Like I can do lsof space -I, and it's going to say command not found. I still can see that they tried to run that particular command. All right. Now, after a while, what's going to happen is the attacker is going to realize that something's not right, and they're going to get bored at this point. They'll probably spend a good 15 minutes on this system, and they're going to get bored, and they're just going to do exit, and then they're going to close out, and that's fine. By the way, I'm super, super excited. I haven't talked about this with anybody yet, but one of the things that we want to talk about is Black Hills Information Security. We usually don't release the vulnerabilities that we find public to the community. We're not a security company that's like, here's all the 0 days we have and all the CVEs. But sometimes we find a vulnerability that's so bad, that's so heinous, that we've been trying to deal with the vendors. We've been trying to get it fixed. And it's been this problem, right? And we have this vulnerability. We actually found out the root password for one of Google's servers. And we think that the server at Google is reusing that exact same password on all of their systems. No joke. What can you guys just give me an IP address of a Google system? Let's see if I can get in with this root password. Anyone, can you think of any IP addresses for Google? Okay, 8.8.8. They're DNS servers. So what we're going to do is we're going to see if this secret root password that we found at Black Hills Information Security actually works on 8.8.8.8. All right. So I'm going to try to SSH into it, and I'm going to authenticate. Okay. I got the key fingerprint. I'm going to go yes on that. It's going to ask me for password. All right. So I've typed in the password. It's a good long password. It's a good long password, but now I'm going to authenticate into Google, and oh crap, I got it closed. I thought I was going to get in on that one. So let me try this again. Let me try to just log into it. Right. All right, exit. Oh shit, I went into my wrong system. Just give me a second. Okay, so now let's do SSH root at 8.8.8.8. Come in, got yes. I'm going to put in the password. Go. See if it works. I'm in. Sweet. All right. So this is totally like the password for one of Google's systems. All right. Some of you are probably freaking out at this point. It's totally not Google's password. Okay. It's totally not Google's password. Let me show you what happened in the background. So if we go back into the background, if I scroll all the way down, you can see this password at the bottom. It's set not Google password. I never left the matrix. Let me walk through that whole scenario slower. Okay. Let me go through it slower. The first thing I did is I logged in to my honeypot. Okay. I logged into my honeypot with just some password. I logged in as root. I'm logged into this honeypot, and the attacker gets bored and thinks that, they're no longer like there's nothing valuable in this. So they exited the honeypot. All right. They exited the honeypot. When I left that connection, it says connection to server closed. And now it says root at localhost. I'm still in the honeypot. I'm still inside that honeypot. It's exactly like that. It's an Inception ploy, right? So now if the attacker does something like this, like they're like, okay, I'm going to SSH into another one of my computer systems, and they go SSH as root at any IP address you put in at this point, any IP address the attacker puts in at this particular point, it's going to come back and say, hey, do you accept this key fingerprint? No one checks key fingerprints. And then it's going to ask for the password. And then any password the attacker puts in, there we go. And we're in, kind of. There we go. Now we're in. So yeah, I don't know if we've ever tried IPv6, but do you see what just happened there? Unless they close the terminal, right? But for many hackers, once they close a connection and it comes back and it says root at localhost, they don't really know that much about their command prompts, and the command prompts change. You're now capturing that hacker's password for another computer system someplace else. So we've completely taken this whole hacker like cyber deception thing where we've crossed the line into capturing the commands the attackers are running. What are they after on that computer system? To crossing the line into now I can gain access to the hacker's password to other systems out there as well. Yeah, Flakinator said, I thought it was odd when I was going to the lab and it never left the honeypot. That's by design. If I type exit, it comes back and it says server connection to server closed. Control D, connection to server closed. It actually captures the Control D. Control C just basically pulls you back. So it's this like Inception deception where it just keeps going. And now you have an attacker that's stuck, and the only way that they really get out is by closing this. But this is powerful because now I start capturing passwords to other services and other systems that this attacker may have access to. So just really, really super powerful technique in this particular honeypot and what you can do with it. So I thought you all would like that. And it kind of shows you just like, how far can we go with this deception stuff, folks? Are you kind of seeing it now? Like we can go a long ways. I'm going to take a couple of minutes, you all, and I'm going to restart my VM. I'm actually going to go through and exit full screen. And I'm going to go back and I'm just going to start up a new stack. But if you want to restart your VMs, you can. Or the other thing you can do if you're using my system is just restart another stack. The point is we have some labs. We're going to be doing some things that may actually kind of start tweaking the previous stuff that we did with IP tables may start tweaking it out. So that's awesome, folks. Like you can go through and you can do this. And now all of a sudden you have this tremendous power over the attacker, right? Just absolutely awesome. Artillery is a tool that kind of takes this up a couple of notches again. It's from the folks at TrustedSec, and it gives you all kinds of things like file monitoring, honeypot capability. And it stands up more than just one port and one service. It'll actually kick out, RPC SMB, Microsoft SQL, VNC, can generate email alerts, and it has some possible limitations on it as well. One of the problems about it, not a problem, but default, it brings up a bunch of ports. It's very easy to identify an artillery server just by the ports that it's standing up. You can pull that down, but you can absolutely change that. You can modify all of those things as well. So we're going to get into more evil web servers. So we just did this for SSH. Now we're going to talk about it for like a web server. What can we do for web servers? And this is something that we love to do, Black Hills Information Security, on the outside of our environment. One of the problems with honeypots, just to give you an idea of some of the problems, is like security scorecard services. If you look at security scorecard vendors, you have like Vanta, you have UpGuard, security scorecard themselves, right? And what these companies do is they literally go through and they scan the internet, and they basically look at the outside of different companies, and they come up with, like a score. And they're like, well, they run outdated software on the outside of their environment, so they get a higher score. They have basic authentication, they get a higher score. They check your SMTP configuration to see how it's configured. And if it's configured insecurely, they'll up your score. Problem with Black Hills Information Security is I love deception and I love honeypots. And security scorecard is constantly getting a hold of us. And they're like, hey, just so you know, your overall security score is a D. You need to fix that. And the only way that we can get our score down, get our risk rating down and get our score going up, is we literally have to pay for this effing service to get them to say, yes, okay, this is a honeypot. We're going to remove it as a finding. And it honestly feels like they're like, hey, that's a really nice series of IP addresses you got there. It'd be a damn shame if something bad were to happen to it. Just total mafia tactics as well. But even with that being said, it almost sounds like a scam service. It kind of does, right? There's a number of different tools that we can stand up fake web services in addition to things like SSH, right? So you could look at like Spider Trap. This is a tool by Ben Jackson in Izmir, and it's like the idea of Spider Trap, but it kicks it up to full PHP, and he calls it Web Labyrinth. So with this particular tool, some of the things that it has that are really cool is Google bots and MSN bots. It'll tell them to go away, which is cool. Also, it has this idea of this random, imagine like a 100-sided dice, right? If the error chance comes out and it hits 16, it comes back and it says 404 not found. If it gets an error chance, hits 23, it says it's forbidden. If it comes back as 42, it comes back and it says payment required. Now, the reason why it does this is some automated application scanning utilities, they'll go through and they'll see if the requests always come back with the exact same response. And if they do, they say, that's a web honeypot. We're moving away from it. With Web Labyrinth, it gives you the capability to kind of start confusing those automated tools by giving them a little bit of spice, a little bit of excitement in the responses that are coming back from that server as well. The other thing that I like about Web Labyrinth is you can feed it a file and it'll choose a random word or a random chunk out of that file, and it'll make each of the words a random directory or an email address as well. So you can mix up the actual text that's being sent into it. Once again, very, very powerful because you can't write a signature based on the text that's coming in. The default that comes with it is Alice in Wonderland. It does full on Alice in Wonderland, pulls the text, and it randomly chooses all of the it randomly chooses the words to make a further directory or an email address as well. So one of my favorite things to do, just to make sure that your team never misses if somebody were to fall into the spider trap thing, is what if you made all the text like indications of a cross-site scripting and a SQL injection attack? So one of the things that I did in the past is just basically fed the attacker snort rules. And the reason why I did that, if you're running an IDS system and the snort rules go through the IDS system, usually the IDS system just like lights up like a Christmas tree. Had to do this with a customer that their SOC team, like it would just generate an alert and say, hey, somebody's hitting the web labyrinth server, and it would generate one alert. And the analysts were like, okay, whatever. And they just move on or go to the bottom of the queue. When we put in the snort rules, or if you go to like OWASP and you just feed a whole bunch of like IDS, it literally is exactly that. Snort starts firing on its own signatures. So it just blows up, and the analysts are like, what the hell is going on over there? Well, somebody fell into our web honeypot, right? So we can take this and we can go further with application specific honeypots. So you can have honeypots that mimic specific applications like SCADA. Conpot is one of them, right? It blends in with existing servers. It basically trips off a whole bunch of different alerts. One of the problems with these tools, though, is you need to go through and you need to change some things. So if we look at our server that we just did, the key fingerprint, the files, the IP addresses, everything in that Keepo server is actually like well-known and documented. Tools like Nessus and Nmap will come back and say, hey, that's a honeypot by the key fingerprint. You can change that. Same thing happens with Conpot. With Conpot, you can change, like look at it and the responses come back, serial number, system name, systems description. You need to change these 4 settings for Nessus not to identify it as a honeypot. We don't have Conpot running in this class because it wouldn't install on the Windows subsystem for Linux for whatever reason. Yep. All right. So let's go ahead and let's do a quick lab where we're going to go through and we're going to do a web specific honeypot right here. We'll just call it web honeypot. In this lab, we're going to run a very, very simple honeypot. It looks like a fake Outlook web access page. And once again, attackers absolutely love this. And one of the reasons why attackers love it is they love the ability to clone it. They love the ability to try to attack it, because if you remember, like last year, even 2 years ago, the amount of vulnerabilities in Outlook web access were just off the charts. We were getting tons of vulnerabilities. So attackers were absolutely going for this as much as they possibly could, right? So you just CD into opt OA web honeypot, easy enough, and then you start it. Super easy to do. Now you're going to get your IP address of your Linux computer system, and then you're going to tail out the dump pass.log from your OA honeypot. Then you're going to open a browser, you're going to serve to it, and you're going to start trying to authenticate. Finally, we're going to show you what an actual web attack looks like. You're going to choose an automated scan. Man, this carbonated beverage is just giving me the hiccups really bad. You're going to put in the IP address of your Linux computer system, and you're going to have it attack it. You should see tons of attacks coming through. And we're going to talk a little bit about this in a little bit more detail on the flip side of this lab. This lab with Zap for some people takes a little while to start up. We're going to resume at 20 after. So do this lab. We will resume at 20 after, and we're going to talk about this, and we're going to get rolling. All right, so get to it. Yet another lab. And then we're doing the Ask Me Anything after we're done talking through this lab. So get those questions ready, folks.
candle for you, burning at both ends. If I have to, pour two for you, pour one out for me.
Welcome back, my friends. I don't usually hack listening to music, but when I do it listening to no bandwidth. All right, so let's go. So you should be able to see my screen now. We good, Ryan? Good. Just need to make sure everyone can see my screen because we're going to do this lab. We're going to go through this lab and then we're going to do Ask Me Anything. So what we're going to do first is this is inside of the Linux portion of the VM yet again. There we go. Let's go ahead and do this one. Let me get logged in, go full screen. There we go. Coming in. So yeah, the whole purpose of this lab is just basically, hey, we can stand up a web honeypot, super easy to do. We got to rewrite. We had this honeypot that we wrote that would basically clone any website, and then it would basically honeypot that cloned website and then generate alerts and things like that. So currently have that as one of the summer intern projects. Summer interns coding so fun. And they're going to be doing that. And hopefully we can replace this lab with something that allows you to go through and, clone any website of your choosing on that. All right. So we're going to run as administrator. There we go. And then we're going to open up an Ubuntu command prompt, and then we're going to surf to this website and just show you that you can actually grab the logs off of it for the authentication. There we go. So I'm going to go ahead and do Ubuntu 1804, and then come on now. Got it. You can do this. I believe in you, Ubuntu 1804, in a cloud instance with a whole bunch of people. I wonder how many instances we have running right now. Let's see what we got here. Ooh, boy. We got a lot of people running this lab. Good to see. Nice to see. All right, so we're going to go into the honeypot. Once again, be sure to thank Arnie Bellini at Bellini Capital on LinkedIn. I don't know if anybody has a link for him to say thanks for making this available. Because literally everyone else, I'm like, hey, how do you feel about making VMs available to people for free? And almost everybody was like, are you effing insane? Like, that's not how this works. It's not how any of this works. And he's like, I'm right there. So love Arnie and what he's doing for the cause here. All right, so now what we're going to do is we're going to start up the web honeypot like so. Like that. Did I mistype? All right, we're in. And I'm going to get my Linux IP address here real quick. Oh, there it is right there. So I'm going to grab this IP. There we go. And then we're just going to surf to it to start. I'm not going to use Chrome because Chrome is set up to be a proxy. So many people, whenever they do this class, they're like, the internet is broken because Chrome doesn't go to the internet. They like kind of associate the entire internet with just the idea of whether or not Chrome can get to the internet as well. While I'm mucking around with this, I'm going to start up Z attack proxy really quick. So I'm going to go start zap. Open up Z attack proxy. There we go. Go ahead and get that loading because it takes a little while. But now when you get this Outlook like honeypot for Outlook web access, you totally can put in anything here. There we go. We can put in any password that we want, and then we can click sign in. It's doing its thing. And then on the back end, you can see like the authentications coming through as well. So we're going to go ahead and do that. And then we're going to open up another prompt, and we're going to CD and to opt OL honeypot. We're going to paste that in there. I think I need to become root, but just do that first. There we go. Paste it in. There we go. There you go. Next, we're going to try trace out that log real quick. And then we should see the authentication request that I put in. There we are. And here you can see there's my user ID and my password that I put in. So that in and of itself is actually kind of cool. All right, that's neat. You can see people trying to authenticate. You can see the source IP address. You can see the user agent string coming in. But I actually want to show you something a little bit more with this with that attack proxy. So I'm going to go ahead and look at the certificate to don't care. And I can close that out. Doesn't matter. No, I do not want to persist this session on Z attack proxy. There we go. Don't want to update anything. We'll just close that. And then we're going to pull Z attack proxy in over here. Oops. Let's just do maximize. There we go. And then we're going to do just a kind of straight automated scan. And we're going to put in the IP address of our Linux computer system, just so we can see what that attack actually looks like on this. And we'll just go ahead and do traditional spider and we'll do attack. Now, when Z attack proxy is running an attack, it's very, very, very similar to what, a standard automated attack platform will do. Now, if we go back to our logs, you're going to just see these logs just exploding all over. And what I want you to see here, let me kill this real fast, is you can actually see the user agent string is coming in as zap. You see that right there? User agent string is zap, 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 zap. And I know this sounds goofy, but just stick with me. Many attackers, when they're running attacks like this, and they're running automated tools, whether it's Z attack proxy or it's burp, or if they're using something like SQL map, they don't even bother modifying the user agent strings for those web application testing products. You could take this however you want, right? You can take this as like a, yeah, what? You could take this as, seriously, it's a cyber deception thing. And that's great. You can actually detect what they're actually doing. That's nice. It's also kind of just a straight security thing. Like you can take like the top 5 web application tools like Nikto, Z attack proxy, W3AF, or whatever. And even Nessus has a user agent string that's really predictable. And you can put in a rule on your web server infrastructure that if anything comes in with those user agent strings, just drop it like a bad habit. Or you could redirect it to another site that is your honeypot site as well. And this kind of, one of the things that you'll learn as you start kind of playing with cyber deception and working with these things over the years is you're quickly going to find out that a lot of attackers aren't nearly as elite as they think they are and as defenders think they are, right? Like you'll see like the news stories of Russia or China hacking into Microsoft, hacking into SolarWinds, hacking, getting access to things from Okta, all of this stuff. And yeah, those are nation state level adversaries and they're scary. But I've even seen nation state level adversaries who don't change their user agent strings. If you have a bug bounty program, right? If you have a bug bounty program, and does anybody here have a bug, leave Okta alone. Does anybody here have a bug bounty program? Just out of curiosity, we got a bunch of people typing. Yeah, we've had them in the past. One of the problems that you have with bug bounty programs, and let me know if you think that this has been a problem, is you have a whole bunch of script kiddies that find stupid vulnerabilities or vulnerabilities that just really aren't vulnerabilities at all. And you have to sift through all the noise of the skidiots trying to say that you have cross-site scripting, or trying to say that you have SQL injection, or trying to say that you have these, when in fact you don't, and they're just script kiddies, right? And then they whine about it, right? So they'll complain incessantly about the vulnerability that they found. And they're like, well, you're going to pay me for this vulnerability. It's horrible, right? The politics and the maintenance of bug bounty programs is awful. What if the really dumb ones just went away? Like really, just imagine if the really, really dumb ones just disappeared. The ones that are the most likely to whine and the most likely to find really, really, really low level vulnerabilities, all you have to do is just put in some filters for some of the user agent strings and some of the tools that they use, and bam, you've just filtered out 95% of the skidiots and the bug bounty programs that are out there as well. Just really easy to do, right? That's what, if the dumb ones went away, we'd have no new hunters. Possibly, I don't know if that's necessarily true 100%, but it is at least something to think about, I suppose. So there you have it. So now we're done for today. We're now into the Ask Me Anything. So what questions do you have for me? It's up to you. You guys control this session and this section of this class. Ask me anything you want at all. Several people are typing. Remember, at Strand JS me, so it's easier for me to find these things. Question is, so that's a great idea. Let me jump up. To redirect requests to scanners to a honeypot, you have a playbook, a list of ideas. Basically, it's this class, right? Like basically it's this class, and that's all the things that I'm kind of putting together on it. Is there a blog webcast that shows how we can secure a home network small business for low costs? I've met multiple small business owners that work from home that want to secure their network properly, but they don't know where to begin to find this help. I don't have one, but we should sure do one. Ryan, do we want to take you? Can you take a note back and just take it back to the content community team? We could do a webcast, how to secure your home network and a small business network. It shouldn't be all that difficult, right? Like set up something like, OpenDNS, right? Set up browser plugin things like Ghostry to shut down, ads showing up in the browser. Really, really, really basic level things that'll actually shut down a large number of the different attacks that are out there as well. So yeah, malware Jake's talk is a pretty good one. You mentioned the sequence number in the earlier labs. Oh my God, I love these questions. The lab is 32 bits and hard to guess. Would an attacker be able to sniff that with Wireshark? Yes, Holy Nick. But if the attacker was going to be sniffing that in Wireshark, they would have to be on the same network as the victim or in line with the victim. And if the attacker is already on your network, you're done screwed at that point. If they're out on the open internet and they're able to sniff that, we are all screwed. The only way that an attacker could actually work that out where they can see those sequence numbers is through something called BGP prefix attacks. Let me show you what that is. Border Gateway Protocol prefix attacks right here. And the way that this particular attack works, when you have ASN numbers, the more specific ASN number for those, let me back up. For those of you that don't know, the internet is broken up in a whole bunch of different blocks. There's roughly 4.2 billion IP addresses in IPv4, and there's a lot more with IPv6. But what happens is these blocks of IP addresses are assigned to things that are like zip codes, and it's ASN blocks. So your ASN block says, I'm responsible for these IP addresses in these ranges. And then all the routers around the world share this like BGP list of which ASNs go to which IP addresses. And it's like zip codes. So these routers become the kind of post offices for these various zip codes. And if you want to send a packet to an IP address, you're going to send it to that ASN's responsible gateway. A really, really simplified version of how BGP works. But to attack that, if you have two ASNs that are broadcasting the exact same IP address, the more specific ASN, one with fewer numbers, is going to win. So that's the only other way that you could do that, Holy Nick. But once again, that risk that exists is no greater than any or all of the other traffic that traverses across the internet every single day. There's nothing inherent about honeypots that increase that risk of sequence number predictions on it as well. We got a question on the YouTubes. What is the best approach of deploying honeypots in production? Should it be in the DMZ? Should you do that on some separate network? Honestly, when you're looking at this, look at this class and see where they implement. And then the other thing is look at the different honeypots that we're doing and say, okay, what of these do I think I can implement quickly and easily and with the least amount of issues? So for me personally, I would recommend, if you're going to do this in order, I would recommend doing a honey user followed by a honey share and then canary tokens in your environment. So these would be the first three that I would implement: honey user, honey share, and canary tokens in your file servers in your environment. None of these require like some massive server infrastructure to do. You can implement them in your environment. You write some rules in your sim and you're off to the races. Super easy to do, barely an inconvenience, right? So that's easy to do. Next, I would recommend looking into file audit would be the fourth one. And then I would recommend like something like port spoof or Cowry, right? So those are kind of the orders that I would put in, but honestly, yep, honey user, honey share. So I'll go through it in the order I would do it. Honey user, honey share, canary tokens, right? Next up, I would look at file audit. Next one would be file audit, and the next one would be port spoof on a dedicated server. So those are some of the things that I would do on that as well. Poor man's sim solution for Soho Elk. There's one called Security Onion. Security Onion. Security Onion is absolutely awesome. I would recommend doing that because it's free. So look at Security Onion for that one as well. How do I feel about the TikTok ban? Look, okay, this is going to sound a bit weird, but some of the stuff that I've read is China is absolutely using TikTok against us, right? Because and it's not just TikTok. Let's be honest for a couple of seconds, right? If you're looking at like Russia, you're looking at China, you're looking at disinformation that shows up on these platforms, there is a tremendous effort by adversaries, and I'm speaking specifically of the United States and Western Europe, right? There is specifically a concerted effort to try to inflame people on both sides of the spectrum. Okay, that is absolutely 100% true. That is happening. It's very well documented. We know that they're doing that. The Chinese have a controlling interest in TikTok, right? So they can use this as a platform to get information, disinformation, however they want to put into a variety of different countries. The other problem I have with TikTok is that the Chinese aren't allowing in like Facebook or like Instagram, which is Facebook, or any of the other like chat-based, social media companies. So it's basically they're blocking a bunch of stuff from the West, and then they're basically having us, just run this stuff that is absolute garbage. Now, some of the stuff, aside from those things, which are true, those are quantifiably true things, is I've also heard some things from various sources that TikTok is basically kind of creating a psyops campaign against the youth of America to completely destroy the youth of America's capability to focus for longer than like 2 minutes. I don't know if that's necessarily. Oh my God, everybody. This is Justin Walker. Come on in, Justin. Why don't you try on one? This is Justin. This is one of my best friends, best man in my wedding. We just got the new Reka hats coming in. Oh, look at that. Dude, did you bend that? Or
No, that's how I came. Yours is a flat brim.
I don't like the flat brims. I hate flat brims. Like this doesn't work for me. Like it just doesn't work. So, dude, it looks good.
Yeah,
It's good. Hey, thanks,
Yeah,
man.
no
Even
problem.
got my size and everything.
I just pulled it out of the box.
It works. It came in my size on that as well.
Did you want this one as a keeper?
I'll keep this one as a keeper because the bill is. Should I take the sticker off? Am I supposed to keep the sticker on?
The young people tell me that's how the ladies know it's fresh.
Really? So I'll ask Erica then. So there we go. Check it out. The new Reka hats. So, all right. Yeah, the hat looks good. Take the sticker off. Let's do a quick blow. A sticker on or sticker off, everybody. What do we think? What do we think? Sticker on or off? I got sticker off over there. We're all coming in. Several people are typing. We have opinions about this, Ryan. Off, off, off. Ooh, it looks like it's overwhelming. It's off, everybody. So we're going to take that off. It's no longer fresh. It's now straight up Reka hat. So I hate the way I look in a baseball cap. I just don't like it. I don't think my ears are big. It's just my ears feel exposed. Like somehow they're now like in danger. Like, a hawk is going to show up and go, and grab my ears and like tear them off. It's not that there's any protection with my standard haircut, but check it out. Rakah hats in the house. We're going to be selling out of those very quickly. So check that out. All right. Is there any honeypot? Oh, no. Wait. TikTok ban. All right. So I believe that the TikTok ban, that's kind of rumor and conjecture that China is using it to destroy the minds of the American youth. So all that being said, there's part of me that's like, okay, I can see why it's banned. But here's my problem with it. Ban TikTok all you want. They're just going to switch to something else. Right. And it may not be the Chinese. It may not be something else. Like we aren't in 1984, everybody. Like that's not the future that we're going into. Like it's not going to be 1984 with an Orwellian overseer that's going to be dictating everything we do. We're in Brave New World by Huxley. If you haven't, go read the synopsis of Brave New World from Huxley. Basically, you have Soma, you have all these drugs, people get all the entertainment, they can see everything that they ever wanted. Just don't think, right? Just don't think. You don't need to think. Here's your drugs. Here's the stuff that makes you feel good. We are in Brave New World. So that's my problem with the TikTok ban. Sure, ban TikTok. It's going to be something else in a couple of weeks. And the way that these algorithms are set up, the way the monetary model is set up for monetizing it, we're absolutely going to be in a perpetual situation where people can take advantage of those things. Now, I do believe that I'm kind of a fan of like, we know that this shit is intoxicating and it is addictive for children. We should set a minimum age for these things, just like cigarettes, just like alcohol for social media. Is it going to stop 100%? Hell to the no. I drank in high school. Was I day drinking all the time? No, I was not. All right. All right. Honeypot's alternative for Windows, like the, yeah, we're going to be going through and doing Windows honeypots for the share the user, which we already did, file auditing. We have a bunch of those things that are coming up here in just a little bit. Do you have a series of classes that you can sign up for? Hack It Now. We can drop it in. I am teaching Intro to SOC Core Skills. If some of the technical things that I'm talking about went a little bit over your head, you may want to go back and take SOC Core Skills. That's where I take apart Windows command line. That's where I take apart the Linux command line. That's where I take apart packets. That's really where we start, like really the beginning of the journey. This class is generally the end of that journey. So please check that class. And also, if you can't take it, but you know someone who would benefit from that class, get them into it. We're trying to get as many people into computer security as we possibly can on that. What is the best way experience with working with VMDR, EDR, or XDR platforms? All you need to do is go to the labs, because it just so happens that we have labs for, if you scroll up to the SOC class, we have labs for Elk in the class on the cloud and Lima Charlie. So you can actually start working with those EDR platforms, and it's totally a free set of labs by these vendors. So you can learn that. And we go over that in the SOC Core Skills class as well. I'm interested in doing bug bounty in the future. If I don't have pen testing experience and try, do you recommend a path? I strongly recommend starting with BB King's web application pen testing classes and webcasts that we've done on web app stuff, and working your way up, doing try hack me's on the web app stuff, because that's where you're going to find your bug bounty stuff. More than anything else, it's going to be a web application pen testing amount of work that you're going to do. All right. Is it possible to build a SOC with 98% freeware? It absolutely is. It absolutely is. But it's going to have some difficulties in maintaining it and updating it. You're going to run into some issues with that as well. What are my thoughts on Teapot? I wish it was updated more. Trying to get Teapot up and running. There's a whole bunch of different components of it that are already out of date. That's another intern thing. Like I want to get interns that are updating all these tools that I teach and keep them rolling on that as well. Security Onion over Elk? No. Seriously, Security Onion is Elk. Just being completely clear. The Security Onion interface is Kibana, and it is Elasticsearch, Logstash, and Kibana. So it really is on that as well. What do we got? How can or should we integrate with these techniques in our SIM? Every single one of these things can generate logs. The only thing you need to do is set up your SIM to be able to pick up those log sources and then you put in signatures and rules with them. So all of these have the capability of logging to files. All of these have the ability to generate logs and alerts. Just take advantage of that as well. It's not just the youth of America. I think that Brian is absolutely 100% correct. It's a problem that exists when we're looking at like TikTok all the way around the thing. Right. Man, I'm just getting to the point where we have the hats. Check out the Spearfish General Store. Justin is the director of the Spearfish General Store. Oh man, I only had like one person that said sticker on. Yeah, Spearfish General Store. Wow. The government of India has banned more than 250 Chinese apps, including PUBG Mobile, TikTok, Shin, and AliExpress. Does port spoof, can it interface with legitimate services that come into the network? Yes. But where you do that colon jam M, where you do that colon, like 1:65,535, you need to do 1:, let's say I want to allow port 80. I would do one rule that's 1:port 79. And then I would do another rule that would be 81 and then to like 442, right? So you can use that colon to define the ranges, but you may have to break it up across multiple rules, Jan, to be able to do that as well. That is so crazy. I didn't know. I honestly did not know that I had no idea that India had banned that many like apps. That's crazy. I lost 10 points on my street cred. Somebody said I should take the sticker off and put it on my chest. All right, I'll do anything for you guys. There you go. You got that there. Really want to trigger people? Somebody said bend the hat a little bit. Yeah, I could totally take the hat and bend that bill. Bend that bill down. Yeah, gets people kind of worked up a little bit. You said about TikTok PSYOP in the US. What about US using Facebook and WhatsApp and other stuff in other countries like here in Brazil? Absolutely, Johnny C. I want to make it very, very, very clear that that is it. So whenever you're looking something like Facebook, what was the Southeast Asian country where they basically were doing ethnic cleansing against their Islamic population? And it was literally, and I think they also did this in Florida, as not in Florida, Jesus, in Africa as well. But there's been numerous countries where things have been absolutely taken advantage of in with Facebook. Myanmar, thank you very much. Absolutely. So we've seen this stuff. The Rohingyas, yes, very good. Christopher nailed it. Like, if you want to see something terrifying, look at what happened with the Rohingyas and the amount of disinformation that was pushed out by Facebook. No, absolutely, right? But this kind of goes too. As human beings, we aren't equipped for this crap, right? Like, we are not built to handle these types of things. Yeah, by the way, enjoy your nightmares tonight as well. All right. All right. Oh, like the Romans did with entertainment to the masses. Yep. Yep. Yeah, crazy. $16-year-old. Some people are saying 16 or 13. Any preference for cloud providers when using honeypots? Not really. I've used Amazon. I've used DigitalOcean. I've used Linode. I have not used Microsoft Azure or Google Cloud Compute, but all of them seem to be working just fine. Yeah, it is absolutely addicting for adults too. But boy, you know, cigarettes are, at some point, you got to let people make their own decisions, right? Oh, sock core skills next week. It's going to be awesome. Wazaa versus Elastic. I like Elastic better. We use it in our sock. It's commercial. It's better maintained. It catches more stuff. But Wazaa, it's kind of free. And you got to have nothing but mad respect for the people that do that as well. How can or should we integrate these techniques in first? Oh, we already answered that one. Do you know any company that takes individual contributors in a way like the mill? None off the top of my head. Okay. People are leaving to go do dad and mom things. Do I pay my interns? Absolutely. Dude, like, okay, let's straight talk for a couple of seconds. any organization that is not paying their interns is powered by Satan. I just think that that's like I think it's the shittiest thing for companies where we're paying you an experience. F you. I cannot stress enough how much that pisses me off. And it's so petty. It's so petty. Like if you're paying interns like $20 to $25 an hour, whatever you pay, that's like nothing. That's like nothing compared to like full-time employees that are out there. Just how it's like we need to not normalize that garbage, right? It cannot be normal. It just cannot be normalized. And I agree, you can't pay bills with experience, right? Just so pisses me off, right? And I talk to other business owners, they're like, well, no, they're getting a lot out of the experience and doing this stuff with us. And most of them have college degrees. Who cares if they have student loans? Like, why are we taking advantage of people that are doing this stuff? Just crazy. Another question. Blue Mountain. What do you think will happen when Neuralink device exploits are loaded into Metasploit? That actually is a good question. Let me see if I can find something for you all. Here we go. Oh, I think I can find it. And that really truly gets into what the goal and objective is of the Future Is comic. And I am going to take an opportunity. I'm going to show you one of our comics here right now. Actually, this particular comic, this is the rough set of it. This is
John,
not...
you're not sharing your screen.
Oh, crap. Hold on. Share my screen. There we go. Now you should be able to see it.
There it is.
There we are. All right. So the Future Is comic is all about that, right? Like what happens whenever we have neural links that actually plug directly into our skulls or augmented reality. So let me see if I can find another one. This is one of the comics. We have two of the comics right now. Oh, where's the other one? All right. I'll just go through this one. So we're creating a comic book, and that's Raka Publishing, right? It's under Raka Publishing. We're doing comic books, and just kind of show this for the next 8 minutes to give you an idea of what we're doing and the quality of what we're doing in this comic as well. So the whole point of this comic is, what does the future look like? And a huge part of it is dealing with neural links. What happens whenever you have augmented reality in the form of glasses? What happens when we get to the point where people can hook things directly into our brains and they can you can augment the universe around you? And that really is a long conversation. And the very first comic book, which is Martina's story, let me see if I can find Martina, because I think it would be better. Oh, I think I found it. All right, I got this one. So I'm going to show you Sally's story first, and then I'll show you Martina's story. So if we're looking at the future, what happens whenever digital rights management and you never really own anything? Like everything, you have to have a subscription plan. And in this particular comic, we have this tractor, we have this farmer that is farming, but for whatever reason, the farming company has locked him out of his tractor, all right? Completely locked him out of his tractor. And this is something that John Deere is doing right now, right? Emmanuel said it's not the future. And the name of the farming company, since we didn't, yeah, dude, absolutely. Like John Deere is doing this right now, okay? And the name of the farming company is EIEIO. So this particular farmer is communicating with Sally. Sally is a hacker that's in space, and she makes it her kind of life's goal to basically hack into the EIEIO satellites and then basically make it so people can do farming. So this is the Sally character. She's in space. It's absolutely gorgeous. Very, very well done comic. And of course, the EIEIO corporation sends this killbot to try to attack her. And she's dealing with that scenario. But it's looking at the future through that lens of, if we look at computer security and we go to some point in the future, we never say how far, what happens, right? And that's just fantastic. That's one of my favorites, is the Sally story. Another one of the characters, her name is Martina. And this gets into that whole what happens when you have an implant in your head. So Martina, she's a Olympic athlete. Her and Sally, and there's all kinds of characters that are kind of like in this hacker A team. But the way we did it in the comic is, you can see this implant in her head. That implant in her head is augmenting her reality. So everything that's in pink and in blue is kind of represented as, that's the augmented reality stuff. And she's on this run, and she's chasing this, I think it's a flying fish, right? But her husband works for a prison company. Okay. And the husband character is a very abusive husband in this relationship. And he can actually gain access into her implant, and he can change what she sees. So here he's seeing all the faces turned into him, because he's in her augmented reality. And all the billboards are all him being really possessive. And she goes to this bar after she's done with the run. Guy tries to talk to her. He freaks out, yells at her. She ends up going to the restroom, and the name of the company is Peregrine, and the name of the software is Penance. And what they're trying to work on is, they're trying to work on a new prison system where you don't have to put people in prison. Because they have these implants in their skull, you can hijack the implants, and then you can wipe out everybody and everything that they see and they hear. So you can't see anybody, you can't hear anybody, you're kind of left on your own, and they can control you at that level. And he tries this out against his wife because, she's being bad, right? And she tries to hack the implant, and then he ends up locking her down. He makes her look really old in her face, and everything goes bad. And then she ends up in the hospital bed on it. But it's talking about what happens when we have these types of things. It's a lot like Black Mirror, right? Now, the difference between this and Black Mirror is, a lot of the hacks that you see that are happening in this comic, you can actually do. Periodically, there will be IP addresses. Periodically, there will be, QR codes, IPv6 IP addresses. And then you're going to be able to then do that hack that was in that comic. So like right here, she's trying to hack her firmware. And you're going to be able to download the firmware from the internet in a bin file, and then you'll be able to hack that firmware as well. So yeah, and I've never shown these pages publicly before, but it kind of goes through and it kind of shows what we're aiming for and what we want to do to answer these questions, right? Like, what happens when augmented reality is the norm? What happens whenever we end up in a situation where, evil corporations are bricking people like their tractors? Another one, like the main omnibus comic, is set on the moon, because why the hell not? It's set on the moon, and there's a super rich billionaire that is set up on the moon, and he's set up this place that it's his utopia. It's kind of like the Fire Festival. And he's bringing up all these young influencers, and he's giving them beautiful studios and access to everything to do all of these amazing things. But what he's actually doing to these influencers is he's draining the blood out of the influencers. And he's basically infusing it into his customers and his utopia. So it's this dystopian things on there as well. So this is kind of what we're looking at, right? We're looking through these things as well. What do you think Elk Stack as a sim was EDR, Saracata? Elk can do anything that you want it to do. It's just how you actually put into it. So yeah, if you missed the Kickstarter, you're still going to be able to get the comics, right? You're still going to be able to get the comics, but the Kickstarter is done. We got funded in like 40 some minutes, and we ended up with like over 470 backers, I think, and like $80,000 in this thing. So yeah, we're putting in a lot of work into these things. 486, that's right, 486. So this is really, really super cool. And we want to kind of change this game up and how, you know, comic books and education and classes like this and CTFs all interrelate with each other. And with that, we're at the end. All right, everybody. I just want to say thank you so much for another great day. Buckle in because tomorrow is going to be one hell of a ride. So get out there and have a great day, decompress, and we will see you tomorrow.